Okay, dear students, let us continue. Okay, our topic. Okay, that is stoichiometric defect got over now, dear students. Imperfection or crystalline lattice. Okay, stoichiometric defect generally what we discuss, the defect which is arises due to the ratio of the same cations and anions will be the same, and it is maintained electrical neutrality in a particular crystalline lattice called as stoichiometric. Next one more important thing, that is defect is called as here non-stoichiometric defect. What is, dear students? Non-stoichiometric defect. Okay, now generally in this non-stoichiometric defect, what are the things will come in the here. Okay, generally we are going to what is classified in this non-stoichiometric in the three types. One is comes under here, okay, metal excess defect. What is, dear student? Metal excess, okay, excess defect. Next one, metal deficiency defect. What is, dear student? Metals deficiency defect. Next one, third one, it is called as here impurity defect. What is, dear student? Impurity defect. This is the three things we are going to discuss. First of all, okay, metal excess defect. Okay, generally how we are going to observe metal excess? Okay, in that two categories we are going to observe. How many, dear student? Two categories. One is comes under here anion vacancy. What is, dear student? Anion vacancy. Okay, next one, second one, it is comes under here extra cations present in an interstitial site. Present in an interstitial site. Okay, these are the two things. Okay, don't get confused here. Metal excess. Okay, for example, in a particular crystalline lattice, okay, metal excess, how can you explain? For example, in particular crystalline lattice, both cations and anions is present or not? Yes, it is present. If the anion number will be less, that means anion vacancy is there, then metal will be obviously excess or not? Obviously excess. Next one, second point, what is there? Extra cations are present in an interstitial site. Okay, then extra cations means okay, positive charge, no, that means here okay, metals will be excess or not. In these two conditions we can explain here metal excess defect. Okay, now first we have to start with, dear students, here okay, metal excess defect. Metal excess, okay, metal excess, okay, defect. In that metal excess, what is there? Generally this defect arises due to okay, the more number of okay, metals will be present in that particular crystalline lattice. Okay, now in that particular, what is there, dear students, here? Okay, first I am taking anion vacancy. What is, dear student? Anion vacancy. In that anion vacancy here, first of all, okay, anion vacancy defect. First of all, what is meant by this anion vacancy? This defect generally arises due to okay, the anion is missing from the crystalline lattice. What is, dear students? The anion is missing from the crystalline lattice and it forms a hole, and in that particular hole, what is, dear student? The electron will go and occupy in a particular okay, hole. In that okay, and to be maintained electrical neutrality. Okay, now if the electron is go and occupy in particular okay, particular vacancy or particular hole, that is called as here F center. What is, dear student? That is called as F center. Okay, now what is F center? Everything we can discuss here. Anion vacancy, what I am taking here, anion is missing. Anion is okay, missing from the crystalline substance. From the crystalline lattice and leaves a hole. Okay, in that particular hole, okay, the electron can occupy or can drop. can be, okay, can drop, okay, in a particular hole, in a particular hole, okay, and the same, okay, electrical neutrality is maintained. Electrical neutrality is maintained. Okay, if an electron go and occupy in a particular hole, that is called as here F center. Okay, look, we can state, okay, that is called as, dear student, F center. What is this F center? We can study here. Okay, now just I am taking here one example. Here A plus, here B minus, here A plus, here B minus. Here what I am taking, dear student, B minus, A plus, B minus, A plus. Okay, now I am taking here A plus, B minus. Okay, here nothing is there. Next one, B minus. What I am taking, okay, here no, okay, same here. Here A plus, here nothing is there. Then what I am taking, am I correct or not? Okay, now what I am taking here, in that particular lattice, what is this missing here? A plus, B minus, A plus. Here B minus is there, dear student. There is no B minus. What I wrote, anion is missing from the crystalline lattice. Anion is missing from the crystalline lattice. Okay, in that crystalline particular anion is missing, and in that particular place there is something. What is something here? The electron will come and trap in that particular vacancy. This is called as, dear student, here F center. This is called as, dear student, F center. This F center, okay, F center, it is generally derived from the German word. Okay, what is this one? Okay, what is called as here? It is generally derived from, obtained from the, okay, German word. In German, this is called as here F-A-R-B-E. That is called as fab. Okay, the meaning of this fab is not called as, okay, this one F center here. This is called, like, it is a German word obtained from here. What is the word? F-A-R-B, fab. That meaning of this fab is to impact color to the crystals. Color to the crystals. That is called as here generally F center. Generally it is called as, dear student, F center. Check it here. There is no anion. Anion is missing here from the crystalline lattice. In that crystalline, okay, anion place, one electron come and trap in that particular vacant. That's why it is called as here, okay, F center. Due to this F center, what will happen, dear student? It will produce the color. It impact the color to the crystals. Impact the color to the crystals. It is come from German word. Okay. Now, if we take it one example, very, okay, good example is there. We can consider NaCl is an example first. NaCl. Am I correct or not, dear student? Okay, now I am writing first of all NaCl, okay, lattice here. Okay, how this one? Same, Na plus, and as well as here Cl minus, Na plus, Cl minus, Cl minus, here Na plus, okay, Cl minus, Na plus. Am I correct or not, dear student? Now, just if you consider, here, dear student, initially, okay, non-stoichiometric defect, generally what we are considering, dear student, okay, the non-stoichiometric, okay, the this defect arises due to the cations and anions will be different. The ratio of the cations and anions will be different, and to be maintained electrical neutrality. For example, okay, now this is the cation. If we consider, this is the, dear student, anion. Now, for example, cations is 100 and anions is 99. Will it be same here? No. That's why it is not maintaining the correct ratio of the cations and anions. Am I correct? Okay. Now, even though the ratio of the cations and anions are not same, okay, but if it is maintaining electrical neutrality. That is a very important thing. That is called as a non-stoichiometric defect. Okay. Now, initially what is there? Na plus Cl minus, how many is there? Na plus Cl minus. 8 is to 8 or not, dear student? 8 is to 8. But it is comes under non-stoichiometric defect. Sir, 8, 8, that is comes under stoichiometric, no sir, but we are discussing non-stoichiometric. Let me finish it first one. Okay, now if you take it here, okay, Na, sodium, am I correct or not, dear student? This sodium, how it will be? Okay, ionization takes place Na plus E minus or not? Na plus this E minus, am I correct or not? In this NaCl, in this NaCl crystalline lattice, if you pass, okay, if you pass some sodium vapors, what is, dear student? I am passing here sodium vapors or Na plus vapors. You enter the crystalline lattice here. I am passing here Na vapors. Then what will happen here? Na, how it is, okay, decompose, ionization takes place, Na plus E minus, am I correct or not? Okay, after you are passing the sodium vapors in that particular crystalline lattice, then what is the, okay, what is the things is happening here? This Na plus ion will be absorbing and will be attracting one of the negative ion or not? Okay, what is the negative ion here? Cl minus or not? Cl minus, then what will happen here? This Na plus will be absorbing the Cl minus and it is forming here Cl minus, no, then it is forming here NaCl. Then I am removing here this NaCl minus here because I am passing here sodium vapors Na plus. This Na plus ion abstracting one Cl minus ion. What is the effect here? What is the defect we are discussing? Anion vacancy. One anion should be removed, missing from the crystalline lattice. Am I correct? This, okay, remove and abstracting Na plus here. Na plus Cl minus gives rise to NaCl formed or not? NaCl formed. Sir, then what is the position of this vacant, this atom, sir? Immediately, already we said here, okay, now here already electron lost one electron. Sorry, sodium lost one electron. This sodium will go and occupy or will go and trap in that particular Cl minus place. Am I correct or not? Then what I am taking here? E minus I am writing. E minus. Am I correct or not? Initially Na plus and Cl minus ratio 8 is to 8. Since we are discussing this non-stoichiometric, the ratio should not be maintained here. Should not be maintained. Then just you have to check it now. I am writing the Na plus and as well as Cl minus ratio. Na plus, okay, now will be same or not? 8 only, check it. 1, 2, 3, 4, 5, 6, 7, 8, same only, 8 or not? What about Cl minus? Just you have to check it here. Now 8 is there before, one Cl minus ion is came out or not? Okay, with the help of Na plus. Then what will happen? It is forming here only 7 Cl minus ions. Now this is stoichiometric defect initially, but this is called as, dear student, non-stoichiometric defect or not? Non-stoichiometric defect. Now this defect is okay or not? Non-stoichiometric defect. Sir, then what about electrical neutrality, sir? Electrical neutrality, you only said no, sir. In any crystal you have to maintain electrical neutrality, then only, okay, the crystalline lattice will be, okay, satisfied. Correct or not? Check it here. Na plus how many is there? 8. Then I can write here each sodium having the plus charge plus 8. Am I correct or not? Come here. How many Cl minus, dear student? 7. Then what is the charge? 7 K. That is minus 7. Correct or not? Minus 1 into 7, minus 7. Sir, it is not comes under electrical neutrality. Don't get. Okay. Then in place of Cl minus, what? Okay, went and occupy here. Electron or not? What is the charge of an electron? Minus. Then that minus also you have to consider. Am I correct? Then plus, okay, check it here. Plus 8, next one minus 7, minus 1, dear student, minus 8, check it here, both will be cancelled, becomes equal to 0. That is called as electrical neutrality is maintained or not? Electrical neutrality is maintained. Okay, that's why this defect is called as, dear student, okay, non-stoichiometric defect. Generally it is comes under anion vacancy. Then if the electron is present in that, okay, particular this one, sir, okay, in place of Cl minus, then what will it be? This electron is there or not, dear student? This electron is here. Am I correct or not? This electron will be absorbing, okay, some amount of absorbing energy. It absorbing, okay, some energy. Initially what is there here? It is a ground state. Am I correct or not? This is I am writing. This is, dear student, ground state. Now electron is here. Electron is here. After absorbing the energy, the electron is gets promoted from ground state to excited state. Okay, now whenever the electron is promoting from ground state to excited state, what will happen here? This is now electron is here. Ground state already we know energy is very high, and what about the stability, dear student? Stability will be less due to energy which is inversely proportional to stability. Next one, excited state, energy will be very high, then come to the here, stability will be very less. Okay, whenever electron is exciting from ground state to excited state, it emits some amount of the radiation. It impact some colors. Due to the excitation of electron takes place from ground state to excited state, then what will happen, dear student? Obviously it shows color. What is, dear student? It shows color due to the excitation of electron by absorbing the energy. Am I correct or not? Now before, if you take it, whatever we are eating salt at our home, then what is the color of that salt, dear student? NaCl. It is white or not? NaCl is white. Am I correct or not? Without this non-stoichiometric defect, the color of the NaCl is, dear student, white. Then what is the reason? Due to the presence of this F center. What is, dear student? Due to the presence of this F center. Simple F center means after one anion is missing from the crystalline lattice, in that particular anion the electron will go and occupy. That is called as here F center. Due to that F center, it impact the color to the crystals due to the formation of F center. Am I correct? Without this defect, the NaCl, initially we are using NaCl now, that is white in color. Next one, with this defect, the color of NaCl is, what is, dear student? The color of NaCl is, what is the color? Yellow color. What is yellow color. If the non-stoichiometric defect is there, that is the color of NaCl is yellow. And next one, some more also there. Li, same like this compound, LiCl is there. Next one, dear student, KCl is there. LiCl, if you consider, now what is the LiCl? This is lithium chloride, pink color. What is pink color? Next one, KCl, if you take it here, this is violet color. What is the, students? Violet color due to the presence of F center. Anion vacancy comes under non-stoichiometric defect. This defect only is somewhat big, dear student. Rest of this is very easy. First of all, you need to understand here very important thing. Something is, anion is missing in that particular place. Electron will go on a trap. That is called as here F center. F center generally it is derived from the word German FARB, fab. What the meaning of fab? To impart the color to the crystals. Now this is the NaCl crystal I have considered. From that, what I have considered? Sodium ionization takes place. This after you are passing sodium vapors in this particular crystalline lattice, this Na plus will be absorbing Cl minus, because both are oppositely charged. No, then it is forming NaCl. In that particular place, electron go on a trap in this. This is called as F center, and initially it is stoichiometric 8:8. Then after one anion is missing, the ratio has been disturbed. 8:7, non-stoichiometric defect. Then electrical neutrality is maintained or not? Check it here. +8, here -7, but due to the presence of one electron, -1 charge, -8 +8 cancel, 0. Electrical neutrality is maintained. Due to this one, due to the presence of this electron, this is this substance is called as paramagnetic substance. What is, dear student? Paramagnetic substance, and it shows color due to absorbing the energy. NaCl yellow, LiCl pink color, KCl violet color, dear students. Please note down, dear student. Okay, dear students, let us continue our topic. Okay, now next one, it is called as anion vacancy over. No, dear student, next one comes under extra cations present in an interstitial site. Okay, what is, dear student? Okay, extra cations, second one, I am writing extra cations present in an interstitial site. Correct not? Okay, in that name is the student extra cations present in an interstitial site. Okay, now in a particular crystalline lattice, what is there? Some the number of cations will be more. It will go and occupy in a particular interstitial site. Now interstitial site is there, that way it is comes under what is the it is comes under what defect, dear student? Again it will comes under, dear student, it is comes under type of Frankel defect. This type of Frankel defect. Am I correct? Okay, now what is this one here? Okay, if you consider same a plus b minus a plus b minus here a plus b minus a plus, correct or not? Okay, now what I am taking here, same one crystalline lattice, correct or not, dear student? In that what is there? Okay, this defect arises due to generally some extra cations is present in an interstitial site, in an interstitial site, and it is maintaining electrical neutrality of the substance or the crystalline substance, that is called as here. Okay, now generally non-stoichiometric defect, due to extra cations are present. Next one, if you consider here initially, a plus versus b minus, how many is there, dear student? Check it here, how many? 2 here, 4, 6, 6 is there. Next one, b minus also 6. This is called as here stoichiometric. But what is our topic? This is non-stoichiometric defect. What I am taking here, some extra cations. Where you are going to? Okay, now I am putting here some extra cation in an interstitial site. In an interstitial site, just have a check it now. The ratio of cations and anions will be different or not? The ratio of the cations and anions will be different or not? Check it here. Okay, a plus now how many? Okay, initially 6 now. After added here 7. Next one here b minus 6. Now it is comes under non-stoichiometric defect. Non-stoichiometric defect. Then what about then electrical neutrality, sir? Electrical neutrality, a plus added here. Okay, check it here. How many a plus? 7 no. That means here charge is 7. B minus, that means how many? 6. 6 no. 6 into minus 1 minus 6. But what is the charge here? Plus 7 minus 6. Is it electrical neutrality here? No. Now in that particular you added one extra cation no, in one more interstitial site, the electron will go and occupy. What is, dear student? The electron will go and occupy in another interstitial site. Another interstitial site. Sir, what purpose it is going and go and occupy another interstitial site? That means here we have to maintain electrical neutrality. We have to maintain, dear student, electrical neutrality. For example, if we are not putting this electron, then what will happen here? Plus 7 minus 6. There is no meaning. There is no neutrality. So then I am adding here one electron. That's why what will happen here? Electrical neutrality is maintained or not? Just have a check it. Minus 6, just including this electron, what is the charge? Minus 1 here, plus 7 minus 7, both cancel, that is equal to 0 or not? Then it is maintaining, dear student, electrical neutrality. Electrical neutrality is to be maintained. The very, very important point this is. Okay, next one, generally what type of compounds will be existing, this extra cations. Okay, let me take an example. Okay, generally zinc oxide. What is, dear student? Zinc oxide, if you consider. Initially how the zinc oxide, dear student? Zinc oxide initially it is white in color. What is, dear student? White in color. After it decomposes in the presence of heat, then how it will be? It is converted into Zn2 plus and O2 minus and how many electrons released, dear student, here? Okay, 2 electrons releasing or not? 2 electrons released by whom? Zinc, because zinc is getting oxidized here, zinc getting oxidized. Then what about here? This one, okay, here the -2 to -2, nothing is changed here. Okay, 2 electrons releasing or not? Now I am taking here crystalline, okay, lattice, okay, Zn 2 plus, here O2 minus, here Zn 2 plus O2 minus. Okay, next one here O2 minus Zn 2 plus, just you have to observe, dear student, there is no any confusion here. Zn 2 plus O2 minus. Am I correct? Now I am taking lattice here, crystalline lattice. Correct or not? This is okay. Now initially if we consider here the ratio of Zn 2 plus versus O2 minus. Okay, how much here? Okay, 1, 2, 3, 4, 5, 6. 6 to 6 ratio or not? 6 is to 6 ratio. Then, but this is comes under stoichiometric defect, but it is comes under non-stoichiometric defect. Now, what I am taking here, some extra cations, some like this here, some extra cations. That means here, generally, what I am taking here, Zn 2 plus, it will go and occupy one of the interstitial site in a crystalline lattice. Correct or not? Okay. Now, I am taking here the ratio of Zn 2 plus versus O2 minus. Check it here. Here one more extra now. Then I can write 7:6. Now this is comes under non-stoichiometric defect. Am I correct? Whether this compound is exhibiting okay electrical neutrality or not, just check it here. How many extra cation? One extra cation you added here, because it is okay. After you added, the number becomes 7. Here 6. Then check it here. Okay, 7 into plus 2. What is the charge? Plus 14 or not? Plus 14. Here each oxygen, what is the charge? -2. 6 into -2, -12. But is it same? Electrical neutrality is there? No. Then what have to do? Then 2 electrons are released or not from zinc. Then we add 1 electron here, and 1 electron is any interstitial site you can write. Correct or not? Because these 2 electrons are there or not? These 2 electrons can come and occupy in different interstitial sites. Okay. Now what will happen here? Okay, here -12, -1, what will happen here? -14 or not? This one here plus 14, -14, both will be cancelled or not? Becomes, dear student, 0. That means here it maintaining electrical neutrality. It is maintaining, dear student, electrical neutrality is maintained or not? This is the very important. Initially the color of the zinc oxide is, dear student, white. Okay, with this okay extra cations are present in this one. Okay, zinc oxide, the color of this one, dear student, it is converted into okay yellow color. What is, dear student? Yellow color. Zinc oxide generally it is white in color. With this defect, due to the presence of extra cations in a crystalline lattice, the color okay of the zinc oxide is yellow. This is very important. Okay, now electrical neutrality is maintained. Next one, what about okay the effect of the density, dear student? Effect of this density, will it increase or decrease? Just take it. Okay, obviously we know one extra cation is there, added or not. Then okay, 65.3 okay grams extra added in that crystalline lattice. So its density of the crystalline lattice will be increases. Okay, density of the crystalline lattice will be increases, so that okay due to the presence of this okay electrons here, the nature of this one, dear student, paramagnetic substance. Paramagnetic substance. This is comes under, dear student, okay, metal excess defect. Next one, very small only, metal deficiency. Third one, it is comes under, dear student, metal deficiency. Okay, in that metal deficiency, okay, what are the things will come here? Second one, case 2. This everything comes under, dear student, case 1. Okay, metal okay deficiency defect. Metal deficiency defect. Okay, same in that metal deficiency defect, dear student, generally okay there is okay the metals will be okay this defect arises due to okay the metals will be what is happening to student, less number of metals. That means here it is mainly applicable for okay what type of elements, dear student? Transition elements. What is, dear student? Transition elements. Okay, now generally if you consider here metal deficiency transition element, if you consider, I can consider here iron. In that iron I can consider here FeO, iron oxide, ferrous oxide. Generally this iron having okay variable valency or not, it is applicable for transition elements, and those elements having okay variable valency, those metal or those element having the variable valency. Iron can have two types of valences, dear student. One is comes under +2, second one comes under +3. Second one comes under +3. Higher valencies, what I am taking? The higher valency elements can be displaces lower valency elements. Lower valency elements. Simply you have to check it. Fe3 plus displaces Fe2 plus ions in a crystalline lattice, and to be maintain electrical neutrality, that defect called as metal deficiency defect. Okay, now let me take a crystal here. Okay, FeO crystal I am taking here. Okay, now okay, Fe2 plus, okay, next one O2 minus, Fe2 plus O2 minus, okay, Fe2 sorry O2 minus, Fe2 plus O2 minus Fe2 plus, here Fe2 plus O2 minus Fe2 plus O2 minus. Okay, now what I am taking here? Crystalline lattice. Am I correct or not, dear student? This is a FeO crystalline lattice. Am I correct or not? Then what I am taking, small point you have to. This defect is applicable for okay those elements having the okay variable valency, and okay which elements generally, which group elements? Transition elements only, no, it contain variable valency. Okay, transition elements. If I consider here FeO ferrous oxide, iron can have two types of variable valency, +2 and +3. Just I consider here FeO, okay, ferrous oxide crystalline lattice. Now what I am taking here, initially what is the ratio of I am taking? Fe2 plus versus O2 minus. How much, dear student? 1, 2, 3, 4, 5, 6. 6 to 6 or not? 6 to 6. Now this is comes under stoichiometric, but our concept is a non-stoichiometric defect. Then what I am taking here? Now the higher valency elements can be displaces lower valency elements from the crystalline lattice. From the crystalline lattice, what I am taking? In place of okay this Fe2 plus 3 Fe2 plus I am replacing. How much? 3 Fe2 plus I am removing, and by adding how many? 2 Fe3 plus ions. 2 Fe3 plus. Just have check it here. I removed okay Fe2 plus here. Okay, this one I removed. Next one, this one I removed. Next one, this one I removed. Am I correct? Okay, just take it. 3 Fe2 plus ions are replaced by 2 Fe3 plus. I am taking here Fe3 plus. How many? 2 you are taking. What is, dear student? Fe3 plus. Next one here Fe3 plus. Fe3 plus. This is okay. What is here? This is empty only. This is empty because 3 Fe2 plus ions are removed from this lattice. Okay, by 2 Fe3 plus. 2 Fe3 plus. Now just check it here. Okay, whether it will come in a stoichiometric ratio or non-stoichiometric ratio. Check it here. Now I can consider Fe2 plus is to Fe3 plus is to 2 minus. Fe2 plus how many now? Initially 6 now. I removed 3. Then what is the ratio here? 3 is to. Next one. How many you added in place of 3 Fe2 plus? 2 no. Check it here. Here 1, here 1, 2. Next one, O2 minus will be common or not? Check it here. 3 is to 2 is to 6. Is it having the stoichiometric defect? Stoichiometric ratio? No. Non-stoichiometric ratio. Non stoichiometric ratio or non-stoichiometric defect. Am I correct? Sir, whether this compound or whether this crystalline lattice is maintain electrical neutrality or not, just have check it. Okay, now I am considering here Fe2 plus. How many charges, dear student? Okay, 2 plus. How many? 3. That means 3 into plus 2 plus 6. Correct? Next one. How many plus 3 is it? 2 into plus 3 plus 6. Next one. Okay, total here plus 12 charges there is 2. Next one, what is the charge of oxygen? Minus 2. Minus 2 into 6 minus 12. Am I correct or not? That means here plus 12 minus 12 both are cancelled. That is equal to 0. That means electrical neutrality is maintained. Electrical neutrality is, dear student, maintained. Such type of defect called as, dear student, metal deficiency defect. Metal deficiency defect. Simple, what I removed, okay, in that particular crystalline lattice of FeO, I removed 3 Fe2 plus ions. 1, 2, 3. In place of 3 Fe2 plus, just what I taken, okay, 2 Fe3 plus ions I added. Okay, correct or not? Okay, higher valence is replacing, okay, lower valency. Okay, so that ratio of cations and anions will be different. It is comes under non-stoichiometric defect. Now it is but electrical neutrality is maintained. That's why it is comes under, dear student, metal deficiency. One metal is not there here. That's why, okay, check it here. 1, 2, 3, 4, 5. What is the ratio here? 5 is to 6. Am I correct or not? Metal is one metal is less or not? That's why that ratio, okay, non-stoichiometric ratio, non-stoichiometric defect. This completed, dear student, and small one is there, that is only impurity defect. Please note down, dear student. Okay, dear student, okay, third one, okay, in that case 3, what will come, dear student, here? Impurity defect. Impurity defect. Generally this impurity defect which is comes under the defect which is arises due to the introduce of some impurities in the crystalline, okay, substance or crystalline lattice, okay, and to be maintained electrical neutrality. Such type of defects called as here, okay, impurity defect. Some impurities we are introducing in a crystalline lattice. It is called as here impurity, and that process called as okay, doping process. That process called as, dear student, doping process. Now, okay, what I am taking here in this okay, impurity defect, okay, example I am considering here NaCl. Simple here, okay. Now in that NaCl, okay, we are adding some okay impurities such as here strontium 2 plus ions. What is, dear student? Strontium Sr. This is called as here impurity. What is, dear student? It is called as a impurity. This impurity which is going to introduce in NaCl crystal. That's why it is called as here impurity defect. Now I am taking here NaCl crystal, Na plus, here Cl minus. Check it here, Na plus and Cl minus. Okay, dear student, okay, I am taking here lattice. Okay, now what I am taking here, okay, in that particular NaCl, okay, crystalline lattice, you are going to introduce some impurities. What type of impurities I am taking here? Okay, Sr2 plus strontium ions. Now what I am taking here, in this, okay, this one, okay, Sr2 plus ion, okay, is, okay, introducing or is adding in place of 2 Na plus ions. This is a very important thing here. Okay, 1 Sr2 plus, okay, that's why it is called as impurity, is adding in place of 2 Na plus ions. Then what will happen in that, okay, crystal structure itself, you can check it here. Okay, now I am going to replacing 2 Na plus ions. I am replacing this, okay, Na plus ion and as well as this one Na plus ion. Just I am writing here, okay, introducing some impurities, that is called as here Sr2 plus. What I am taking, dear student, Sr2 plus. Okay, now one, okay, impurity, it will go and occupy in place of 1 Na plus ion. Sir, then what about here? It will be leaving, okay, some vacant. It will be leaving vacant. Okay, that's why such type of defect it is called as, dear student, impurity defect. In this impurity defect, this is a very important, okay, what is here? Okay, 1 Sr2 plus ion is adding in place of 2 Na plus ions. Initially, okay, without adding this one, okay, the ratio of Na plus and Cl minus, how much, dear student? 8:8 or not? 8:8. But after you taken this one, okay, what will happen here? Na plus, okay, and Cl minus, what will happen? Na plus becomes here 6, correct or not? 8 minus 2, 6. Next one here, Cl minus 8, and you introduce 1 Sr2 plus or not? Sr2 plus here. Okay, okay, this is 1. Now that's why it is called as here non-stoichiometric defect or not? What is it, dear student? Non-stoichiometric defect. Okay, now whether it is maintain electrical neutrality or not, just you have to check it here. Electrical neutrality, I am writing here Na plus and Cl minus, okay, and okay, I can take it here itself, Sr2 plus and Cl minus. Na, how many, dear student, now? 6 or not? That means here each one having the plus 6. Here what is the charge? Okay, plus 2. Am I correct? Next one, how many chlorine atoms is there here? Chloride ions. Okay, minus or not? That is minus 8. That means here plus 8 is to minus 8, both cancel here. 0 or not? That means, okay, it will be maintained electrical neutrality. It will be maintained, dear student, electrical neutrality. Okay, this is a very important concept, okay, in non-stoichiometric defect, dear student. Okay, dear student, in that, okay, crystalline defects we generally classify into 2 types, stoichiometric and non-stoichiometric. Stoichiometric, what are the things will come? Vacancy defect, interstitial, Schottky defect and Frenkel defect, and how the defect, okay, what are the things, what are the characteristics, everything we discuss, effect of the density. Next one comes under non-stoichiometric, ratio of the cation and anion will be different, but it has to be maintained electrical neutrality, that is called as non-stoichiometric defect. In the non-stoichiometric defect, generally we are having the 3 types. One is metal excess defect, next one metal deficiency, next one impurity defect. In that metal excess, generally how it will be takes place with respect to metal excess 2. One is anion, okay, vacancy. If the anion number is very less, okay, then metal excess will be. Next one, extra cations are present in an interstitial site. That's why it is called as metal excess. Second one, metal deficiency. Okay, that is especially applicable for the, okay, those elements having the variable valency, variable valency for the transition elements. Okay, higher valency elements replacing lower valency elements. Next one, impurity effect. We have to introduce some impurities from the external side into the crystalline substance, that is called as impurity defect. Now in place of 1 Sr2, okay, in place of 2 Na plus ion, I added 1 Sr2 plus, okay, added. This way it is called as impurity. Okay, dear student. Okay, and whatever you take any defect, finally we have to maintain electrical neutrality. Okay, dear student, I hope everyone understood. Please try to practice and watch our videos. Thank you, dear students.